later on today or maybe by the end of the week. A couple of housekeeping things. If you put your cursor up at the top of the screen, you'll get a little drop-down menu, and one of those options is the chat window. So you can bring that up on your screen, and you can send questions to Rich and I throughout the presentation. If we don't get a chance to answer them today, we will be saving all of your questions and sending you the answers to all of the questions in an email, in a follow-up email. So I wanted to let you know about that. I am recording the session, so also we will be sending you a link to today's session along with the question and the answer. Somebody's asking about part one. So I think most of you were here in part one. This session is going to go a little bit deeper into probes. We had so many questions and so much enthusiasm about our first webinar on probes that we thought we'd handle some of those questions for anyone that wanted to come to part two and kind of go a little bit deeper into probes. So that's what we're going to do today. So it's certainly not a rerun of part one. You can get a link to part one. Well, maybe we'll send out both of them when we send out that email later this week. But just to let you know that we'll also send out a copy of all the slides that we're using today so that you'll have that. Rich has put a lot of resource information on that as well. So I think that's it. Okay. So my name is Pat Cameron, and I'm with InterMapper, and I'm kind of just the host for today's webinar. Rich is the one that's doing all the heavy lifting today, so he just had me come along to kind of do the housekeeping of it. But I want to welcome Rich Brown. He's one of the founders of Dartware and also one of the creators of InterMapper. So we are really lucky to have him around and to help us learn more about probes so that you guys can all get entered in our probe contest. So welcome, Rich.
Okay, well, thank you very much, Pat. I too want to thank everybody for their enthusiasm for coming to this session. At the conclusion of the part one session, I realized that there was just a whole lot of other stuff that people need to know to write really good probes, and so I'm happy to present this additional information. Last time focused a lot on the mechanics of creating a probe file and building them and getting them into InterMapper, and so you'll probably pick it up from what I say today. You're certainly welcome to go look at the recording of that webinar. And today I want to talk about a lot of goodies that I just didn't have time to talk about. And so this is sort of my agenda. I want to talk about MIB files. SNMP tables are an important part of most any device, the information that a device keeps. There were a lot of questions about traps, SNMP traps, and then some things that you need to know about parameters in the SNMP device properties. I did a little bit of troubleshooting last time, and I want to do a little bit more, and I want to cajole you to think about version control. So let's jump in. Probably the biggest question that came up from last time was, well, how do I find out what information is available from my gizmo? The answer is that SNMP information is always described in a file called a MIB. MIB stands for Management Information Base, which doesn't mean anything. It turns out the guys that invented SNMP were really smart, but they weren't good at picking names for things. And so don't worry what a MIB, the words that a MIB stands for, but what it does is it's a text file, and it specifies the variables that a device supports. So maybe a temperature, maybe a bytes per second, maybe humidity, maybe CPU utilization, maybe a bunch of things. So it represents the variable, which has a human readable name and also a numeric OID. If you were here last time, you saw that they start out usually 1.3.6.1.2.1. blah, blah, blah. And then the MIB file also specifies the variable's definition. So exactly what is that a measurement of? Every SNMP speaking device will have at least one MIB. A lot of them have multiple MIBs, so that there's a MIB for talking about how much traffic a device is sending and receiving. There can be another MIB for an environmental sensor might have traffic information, but it also would have temperature and humidity and light levels. So a device we say can support multiple MIBs. MIB files are a pain to deal with. They're written in ASN1 format, which seemed like a good idea at the time, but it was way more complicated than it needed to be. The order that you work on MIBs is important because one MIB may require that some other MIB is present, and then each OID, each object ID, is very likely dependent on previous OIDs, so it's a real pain. So let me show you a typical MIB file, and I'll show you what I'm talking about. So this MIB is called RFC 1213. It is probably the fundamental MIB in all of the internet. It talks about what kind of device it is, and it also gives information about traffic on all the interfaces. And so you can, I'll give you a hint that InterMapper's SNMP traffic probe queries values from the RFC 1213 MIB, it's also called MIB2, to get information about the sys contact, the sys name, sys description, as well as all the traffic on the interfaces. So the MIB file goes on, but basically the format of it is that there's a variable name, sys description, and it's an object type, and it has a syntax and all this stuff, but then the other juicy part is there's a description of it. And so sys description is the textual description of the entity. It should contain the full name and version of the system's hardware type, software operating system, and network software. So this is kind of interesting stuff. I'm going to skip down. There's sys uptime. This is the time that the device has been operating in hundredths of a second, not seconds or milliseconds, but hundredths of a second. There's a sys contact. This is the person that's responsible for the box. You can also put phone numbers and that kind of thing in there. And so the MIB file goes on and on and on. The MIB2 also defines some things that we talked about last time. So, for example, there's the IF speed, which is the interface speed. It's an estimate of the interface's current bandwidth. The IF physical address, this is the MAC address. We looked at IF in octets before, and so you just see this is this describes all these variables. Now, okay, so I want to know, how do I query the IF in octets? Well, IF in octets is defined as IF entry followed by 10. So the last thing, there'd be a whatever, but IF entry, well, what is IF entry? So if you scroll up, I'm going to scroll up, and it turns out that IF entry is IF table followed by 1. Oh, well, that's useful. Okay, so what's IF table? IF table is interfaces followed by 2. And so you have to try to build this whole model in your head, which is really hard. And that's why you need a tool. And so the first tool I'm going to show off is a program called Mibble. It is it's an SNMP MIB browsing tool. So if we scroll to the top here in the text editor, here's RFC 1213 MIB, definitions, : equal, begin. This is the same file viewed in Mibble. And so this, you can scroll through and you can see all exactly the same thing. But that's not the best part about Mibble. Mibble shows, actually parses the file, and if you click on one of the variable names in this pane on the left, what you see is, okay, there's a variable called sysdescription, and it says it's a textual description, so it shows you the same text. But better than that, Mibble has done all the work to say this is the full numeric OID of this variable. Sys uptime, here's the numeric ID. And so actually, Mibble does all the housekeeping and parses it out to tell you what's there, what the OID is. The other thing that Mibble does is it's an SNMP query tool. So if I click on sysdescription, I can actually go to the bottom pane here, and here's the IP address, which is my local laptop on port 161. The read community string, remember this is like a password. It happens to be public on my machine. And here's the OID. And I'm going to click on the Get button. And sure enough, so Mibble goes and it requests this OID 136.121.110, and back comes hardware, Intel 64 family, blah, blah, blah. And it's Windows 6.1, so you could find out all this juicy stuff about my Windows laptop. So this is what Mibble does. It does two things. It makes it a lot easier to figure out, to read the MIB files. It also figures out what the OID is. And I'm gonna actually, this is a good place to point out the difference. You'll notice here this OID 136.121.1.1. The OID that gets retrieved is the same thing, but it has a .0 at the end. I'll get to this when I get to SNMP tables, but sysdescription, sysObjectID, sysUptime, sysContact, all of these variables are called scalars, meaning there's just one single value for sysdescription. And so in SNMP, you stick on a .0. It's sort of like you're requesting row 0 for this variable. We'll come back to this when we start talking about tables, where the last digit or the last set of digits is, think of it as the row number for describing that table. So, so this is Mibble. This is a really powerful tool. It's open source. It's free. And you can download it from mibble.org, or actually we made some modifications to it that make it a little bit easier to use and a little more comfortable to use. And so in the note we send out, you'll see we'll give you a link to the better version of Mibble. So let me go back to my presentation. So we talked about MIBs, talked about Mibble, and then I do want to talk about SNMP tables. SNMP tables contain a lot of data for a particular device. Last time we talked about the IF table that comes in MIB2. It's the interface table. IF is short for interface. And on any particular device, router, switch, even your local computer, there are lots of interfaces defined. And what the IF table does is it gives a lot of information about those. Let me show you a way to look at the where am I? There we are. About this. In InterMapper, there's an SNMP table viewer probe, and so let me show you how to set the probe and see where this is. So it's in the SNMP category, the table viewer, and it shows a bunch of tables: the interface table, the extended interface table, traffic counters, and all. And let me open the status window, and we can see this. So here we are. This is the same thing as the SNMP traffic probe, except that it has these underlined links that say view the interface table. So I'm going to make this window bigger so you can see it, but we have all the columns that are in the interface table. There's a description column, which appears on this just to have, oh, interesting. This is text stored in bytes. The link type is software loopback. The link speed is these are all loopback interfaces. So here, let's look at interface 11. This is a megabit interface. It's a tunnel interface. So you can look at the link speed. Here's the MAC address. And remember, we talked about IF opera status last time. This is up or down. Oh, I meant to show you that in the MIB. So let me go back to Mibble for a minute and show this. I'm going to look at IF opera status, and what you see is here's the variable IF opera status, and its type is an integer. So when InterMapper requests IF opera status and gets a value back, it gets back a number, and the number will be 1 or 2 or 3 according to the MIB. But the MIB assigns the string up, the letters up to value 1, assigns down to value 2, and testing to value 3. And so InterMapper receives the value 1, 2, or 3, looks into the MIB to come up with the string that's displayed here. And so this just makes it easier to write probes. There are other tables in the table viewer probe. There's the IP route table to show the routing that occurs in that device. The IP net to media table shows is the ARP table. And so you can see these are all the MAC addresses and the ports that my laptop would use to talk to those various devices. So I wanted to talk about the table viewer and say this is pretty powerful to make these table viewer probe. So the very next question you're going to ask is, how can I get one? These look really cool, and it's pretty straightforward to do it by hand, but it's also pretty fussy work. There's a lot of variable names that you have to get exactly right. The syntax within the probe it's not impossible, but it's a little tricky. So what I'm going to do is show instead a nice tool that we've built called the MIB Viewer Probe Builder. So what this is a web-based tool. I'll send you a link to this as well. And I'm going to select all of this MIB file, copy it, and click over here and paste it in. And so here you can see, here's the MIB, paste it in. And then I'm going to click Create the Probe, or you can also hit the Tab key. And you'll see what happened down here in the bottom of the window is a fully formed probe. Everything here in this blue background is a full InterMapper probe. There's a comment at the head of it. It's got a description section. It has the header section, and the header section, custom SNMP probe, the package and probe name are com.dartware.viewer.rfc-1213 MIB. Now that came from the MIB name over here, RFC-1213 MIB. There's a human name, it's a display name and all. It doesn't have any parameters. It has a lot of SNMP device variables though. So remember, there was a variable sysdescription, and the human name for it is sysdescription, but it's got a .0 because it's a scalar value, sysobject ID, sysuptime, and so there are a lot of these that are defined in the MIB. I forgot to say at the beginning of this piece section that people say, I got a MIB from my vendor, can you make me a probe? And the answer is, you can make your own probe now, because you just take the MIB, paste it in here, and then hit the tab key, and you get a full probe. I didn't talk about it, but I think it's a good time to do it. There is an SNMP device variables, which we looked at last time. There's also an SNMP device variables on demand. This is how you define tables. So in an SNMP probe, there's a table called IF table, and it has a column named IF index, and here's the variable to use to get it. There's an IF description, IF type, et cetera, et cetera. This is what generates the internal representation of the table. They're called on-demand tables because InterMapper doesn't continually query these. InterMapper only gets values from the table when you click that link. So that's where the name on-demand comes from. So I have an on-demand table called IF table, and so let me scroll down to the bottom of the, here's the SNMP device display, and it's got sys description, it's got sys object ID, sys uptime, and all of that. I'm going to scroll all the way down to the bottom, and then remember there was a variable called IF table. There was a table called IF table. Well, here's its definition. $curly IF table, and then whatever comes after this colon is what you see in the status window. So we have view the IF table here, and $curly IF table colon view the IF table, view the AT table, view the IP adder table, and so on. So this is how you build an SNMP table in your probe. The best way to make an SNMP table is to let this web page do the heavy lifting. Let this web page do all this typing, because that's not very interesting typing. If you want to make a probe doing this, and you surely should, these probes, as created by the MIB viewer builder, they're not eligible for the probe contest. That would be too easy. But what you can do is go through, make a nice description. I mean, this is a pretty bare bones description that said this is RFC 1213 MIB. Make a nice description and describe what it does. You might want to pick and choose from the variables in the MIB. Not all of them are interesting, and so get rid of the ones that aren't interesting. You could make some parameters to say and put in some thresholds that we talked about last time to say, well, if this value that comes back from the device is greater than this threshold that I've created in the parameter, put the device in alarm or warning. That then becomes a very useful tool, obviously for you and for everybody else on the InterMapper list, so that would make a probe eligible for the probe contest. So definitely look to this tool to build a MIB viewer probe, cut it down, modify it, tweak it up to put some thresholds and put some intelligence into it so that it can really test a device and get your entry into the probe contest. Good. So that's SNMP tables. I want to move on then. Another big question from last time was, what about SNMP traps? And this is another instance where the guys that designed SNMP had really good ideas and really bad names. A trap is nothing more than a notification that's sent by the device you're monitoring without having InterMapper solicit it or query it. So it's good in a lot of circumstances. You might have a lot of devices that you really only want to check every 5 minutes because you don't really have to be right on top of things. But it means that it could be 4 minutes and 59. If you query it now and then a second later something goes bad, then it can be 4 minutes and 59 seconds before the before InterMapper notices there's a problem. So a trap is a message that the device can send to InterMapper, and it does two things. When InterMapper receives a trap packet, it does two things. First off, the trap packet contains a bunch of OIDs and their values. This is just as if InterMapper had sent a request for those OIDs and those values. The trap arrives. InterMapper parses out that information and then sets variables within the probe just as it would if it had queried those, and then uses it within the logic of the probe to make decisions to set the device status and all. The second thing that a trap does is it tells InterMapper that it's a really good time to repoll the device. So it means the device has decided that something interesting has happened, and that it sends a notification, it sends a message, the trap packet, to InterMapper to say, this is something that's happened. A lot of times you don't have to do any formal processing of the trap because the InterMapper probe itself repolls and it will notice and detect the problems that are there. There is a section. There is a section about in the developer guide about traps. You can read more about it and see how to build your own trap packets, trap probes there. I didn't have a chance to describe some other kinds of probe parameters. Remember, in a probe, the parameters section is how you accept input from the person using the probe. So let me switch over to my parameter test probe. Remember, there's a parameters section that has a number of fields, a number of lines that give customers a place to enter the data. Let me switch to InterMapper as well, and we'll look at the first. We'll look at the set probe window. So we have in this probe, we have a parameter named text, a parameter named password, parameter named check me, true, false, and a parameter named 5 choices. And if you look at the set probe window, you can see there's a parameter named text, there's a parameter password, check me, and 5 choices. The text is just a straight text value. There's no surprise there. Password has an asterisk at the end of the name, and the text that you type is bulleted so that it's hidden from view. The next parameter is check me, and it has 2 values in square brackets here, true and false. InterMapper treats that as a checkbox so that you can check it yes or on or off. And then a parameter with more than 2 choices in the square brackets is automatically formatted as a drop-down. So we've got a drop-down with 5 choices: OK, warn, alarm, critical, and down. If I choose down and click OK, I've also got logic in the probe here in the threshold section to say if 5 choices is equal to the string down, set the device's status to be down. And so you see it's blinking red there. I'm going to change it because it makes me crazy to see things blink like that. I'm going to set it to warning, click OK, and it goes to the yellow warning state. So that's additional things that you can do in the parameters section of the probe. I realize I missed a piece of the SNMP Traps, so I'm going to go back to this, and I'm going to also switch over to my demo. InterMapper has built in a probe called the SNMP Trap Viewer Probe. Remember, a trap is a message that just arrives out of the blue from the device. And so we made a trap viewer probe to show the contents of the trap, to show what information came in from the trap. I'm going to open the status window here. And so the status window is got the standard stuff at the top, but then information about the trap, it's all set to unknown. What this means is InterMapper has not received a trap for this particular device. Now I'm going to switch over to another computer here and see if I can. Excellent. The magic worked again. I just had another computer send a trap packet to InterMapper, and the trap viewer probe fills in with all the information that came in. So the community string that was sent in was public. The timestamp happens to be the number 4567890. The agent address, meaning the address of the device that InterMapper's watching, is 192.168.254.9. The sender is a different computer. It's .24. I'm not going to get into all the details of the traps. That's also described in the developer guide in the section about SNMP trap probes. But using the trap viewer probe is a really good way to get a handle on the traps that arrive and figure out how you can get good information from them. So that's about traps. We talked about the probe parameters. So what can go wrong? One of the things that it's easy to tell how you should make your probes. As you're learning to do it, there is a lot of fussy syntax. There are a lot of mistakes that are easy to make, and I wanted to show some common problems that you're going to run into, what indications you'll get when things don't work right, and what you can do to fix them. So I'm going to switch over to my text editor, and we have a probe that I called the Everything's Wrong probe. It has lots of mistakes in it, so that you can see what's there. The first mistake that I'll talk about is the one that I did last week, and I am so proud of all you people for paying attention. I purposely put a typo in the OID name, and InterMapper gave a message, but I guess Pat got a dozen or two people sending in comments. Oh my gosh, he's making a mistake.
We did. It was great. It was pretty funny how everybody caught on to that.
So I hope you're all still awake. So here's the probe. This is the probe as we've got it. I'm going to switch over to InterMapper, and I am going to. This has been saved. So if I didn't talk about it. So we'll go to the set probe window, and go to the test, and I'm going to refresh the probes. There was a probe with an error. So I'll click OK, and it said to open the event log window to see what went wrong. And so in the event log window, we see this message here that says com.intermapper.snmp.everythingwrong.text error parsing OID IFOT octets.13. So InterMapper, when InterMapper read the probe, it saw this name. It looked in the MIBs to see if it matched the name and said, I don't have a name that matches. And then it generated this message. So let me fix this. So type it correctly, IF out octets. I'll save it, and I could come here and set info and set probe and click this reload probe buttons, but it's a lot easier just to hold down Control, Shift, and R on the map, and then probes have been updated. One new probe was added, no probes were updated, and so now if I open the Set Probe window, we go to Test, there's the Everything Wrong probe, and I'll click OK. And we open the status window on this. So in the status window, we've got received traffic, transmitted traffic, wrong variable name, and IF out octets num. And there's some errors here. So where do these come from? So let's just see. There we go. Okay. So the undefined IF out octet SS. So I have in the SNMP device display on the wrong variable name, I have a variable in the curly braces called IF out octet SS. But of course there's no variable IF out octet S. There is one with a single S. And so that one is shown here correctly, but it's if I've mistyped the InterMapper variable name, it shows up as an undefined IF out octet SS. So this is, if you see this, you know you've got a typo someplace. There's another error that can happen in IF out octets num. I decided instead of using the human readable name and a row number, I just type in the full OID 1.3.6.1.2.1.2.1.16.3, which is almost exactly correct. It really should be 221.16.3. And so what InterMapper is going to do, it's going to send a query to that device and say, I want this OID. And the OID sends back a response, no such name. This is an SNMP term that says, hey bucko, there's no such name, there's no such OID as the one you asked me for. And so that's a different indication. InterMapper sent an OID that the device doesn't know how to interpret. That could be either because you have a typo, because you've got the wrong digits in the string, or it could be that you're sending the OID for a MIB that the device doesn't support. If you send a request for an OID for an environmental variable, so you want to get the humidity level, and you send a request with an OID for a humidity level, and you send it to a router that has no idea what you're talking about. The router is going to respond with this no such name value. And then you know that there's just some mismatch. So that's another error to be aware of. Let me think. I don't know if you noticed, but let me switch back to the InterMapper map. In the Trap Viewer status window, the initial state of all the variables was unknown. That means that InterMapper hasn't yet received a value for it. Once the trap came in, almost all these values filled in, and so InterMapper could display them. The trap that arrived happened only to have 6 variables in it, and so variables 7, 8, 9, and 10 remain unknown because they haven't been filled in. Another error message that you'll see sometimes is the too big error. This is another SNMP response that you'll occasionally see. InterMapper tries to put multiple queries into the same packet. So typically it'll try to put in 10 or even 15 variables into a single request packet. So that it's just an efficiency kind of thing. InterMapper says, well, we've got 15. I'm going to request 15 variables. I could send 15 request packets and get 15 response packets from it, and get all the answers. Or SNMP allows you to put multiple queries into the same packet, and so InterMapper asks for variable 1, 2, 3, 4, 5, 6, 7, 8, 9 in a single request, and generally the response comes back with the values for 1, 2, 3, 4 variables 1 through however many, and that's all fine. Occasionally the response is too big to fit in a single packet, and so I believe what happens is that the values that do fit come back in the packet, and InterMapper can get those values. But the packet itself comes back with a too big error, which tells InterMapper that there's just not all the data could fit in the response packet. And the way to fix that, it's actually it's in the probe header itself. I'm looking here in the set probe window. The way to fix that is to use the SNMP device properties section. There's a max vars equals and then some number, and that tells InterMapper, don't put as many as you can into the packet, but just put in this number. And so a safe thing that always works is to set max vars equal to 1. And that forces InterMapper to put each query into its own packet. That's good because it'll work. That's of course bad because it's not quite as efficient. It's not a disaster. You're better off monitoring the device and having a few extra packets in your network. That's Rich Brown's opinion. So those are some troubleshooting techniques. I wanted to take a minute and talk about version control. You've all done, I don't know how many of you are actual professional developers, but if you're making InterMapper probes, I appoint you. From now on, you will always be a professional developer of software. And as you do work on your probe, you make a little change, you check it, yep, that works, and then you make another change, and yep, that works, and that's the way this stuff has to work. And if you want to put a stake in the ground, just to, okay, this piece is working, this is pretty good. Let me save this. You could say, well, I'll save this as probe1.txt. And then I'll make some more changes, but I'll make those changes to a file called probe2.txt. And then, okay, all right, that's working pretty well. Let me make probe3.txt. And that's actually not good. That's a disaster because you've got all these funny probes left over. You're up to probe43.txt, and you broke it. And which one was okay? Was it probe 42 or was it probe 41 that was, you know? And it's just not a good way to work. And because you've got all these files lying around, and you have to try to remember which one was better than the other. And there's a better way. There are a lot of tools that do version control. InterMapper works really well with the two. I think they're the most popular. The one's called Git, and the other one is called Mercurial, and it's abbreviated HG. InterMapper uses Git for its own internal source control. I like it. There's a really nice GUI program called SourceTree that allows you to manage this, and I use that. I use that exclusively for any kind of development that I do. A nice thing is that SourceTree works nicely with the GitHub.com site, which is in fact where I posted the all the probes and things from the last webinar session. So you can grab the files there. I'm going to show you a little bit about SourceTree, and just to show you how it works and give you an idea why I'm so hot on it. SourceTree and the Git program itself are all free, and so there's real value there. Not only do they save you a lot of work, but they make it so that you don't have to worry so much about making mistakes. You can always go back to a previous version. What we're looking at here is the program called SourceTree. I'll send a link to it. It's from an outfit called Atlassian. They sell a bunch of tools, but SourceTree right now SourceTree is still free. I don't know that they have any plans to charge money for it. What I'm looking at, there's several ways to look at it. If I look at the file status, these are all the files in my InterMapper settings in the probes folder of the InterMapper settings. And so there's a README, there's a com.intermapper.snmp.everything. I should say everything wrong. Here's the MIB viewer for RFC 1213, the param test trap. These are all the probes that we've talked about. If I click on this is the file status. If I click on the log history, what I see is a series of the changes that have occurred to these files. So the very first thing I did, I created, it's called a repository. I created the repository for the version control, and I said include everything that's in the InterMapper Probes folder. And then I made a series of changes. There's a stunt that you can say, oh, don't keep track of certain files. And the built-in zips file, built-in probes.zip file that's in the probes, don't track that. Don't pay attention to that because it's going to change from time to time. I then added some new probes for the RFC 1213 MIB viewer and the SNMP Trap display. The file was already there, but the README file that's displayed in GitHub just talked about the InterMapper webinar part 1. Well, I made some changes to it to talk about part 2, and so what you're seeing here is a built-in difference program as well. Let me make this a little bit bigger. So the line that's in red is the original file, and then the line that's in green is its replacement. So it said, the original file said creating InterMapper Probes webinar, and then because there are now 2 of them, creating InterMapper Probes webinars. This repository contains all the files mentioned during the, and then these 3 lines were taken out and replaced by these 2 lines. I took these 3 lines out. And so it's pretty straightforward to see what changes you've made to your program, to your file. This is useful in a this is useful when you're creating probes. Okay, I made a bunch of changes. I'll commit it, make some more, check it, make some more changes, commit, more changes, commit. And then, because you can see the difference between the commits, you can say, I broke it. What are the changes between when it worked last and what I have now? This is what the differences show. I still have some uncommitted changes on this. So this was a previous revision. I made some more changes, and in fact, I made some more changes to the README file, and I made some changes to the. Oh, right. Here's the old. This is the everything's wrong with the misspelling at IF octets, and I made it to IF out octets. What I'm going to do is I'm going to select both of these, right-click, and click Commit. What will happen is so I made 2 changes. I updated the README file and I fixed the typo. And when I click Commit, Git remembers these 2 files and remembers those changes so that I can now make further changes, but know that I can get back to this file state. So that's version control. It's really valuable. It's very straightforward to set it up on, for example, the InterMapper Probes folder. And if you do anything modifying or keeping track of text files in your life, then you need to then you should think seriously about putting it all in version control. So let me go back to the presentation. We talked about these probe editing tips, but I think it's worth refreshing them. Probes are just text files. They live in the InterMapper settings probe folder. You should always, always, always put a .txt suffix on the probe file name. It just makes it works more nicely everywhere else. InterMapper doesn't care if the suffix is there, but it's easier for everybody else to use. When you've made a change to a file, you reload the probes. You can do that from the Set Probes window, or you can hold Control-Shift-R, or on a Mac, Command-Shift-R. You can expand the built-in probes.zip to see what's there. We talked about MIBs and importing them, and you should definitely use version control. I'm winding down. This is a list of resources that you can use. We're going to send this information as well as sort of a summary of this webinar when we're done.
Fabulous.
Okay, thank you.
All right, thank you, Rich. We haven't had a lot of questions come in. You must have answered everyone's questions, Rich, so that's beautiful.
Okay.
There is one about SNMP v3 and the community string.
Sure.
Yeah,
I can talk about that. In SNMP, so there are 3 generations of SNMP. SNMP version 1 was a really good first cut. It carried people along for a good long time. SNMP version 2 was invented because there had to be some extensions. We talked briefly about counters last time, and SNMP version 1 only had 32-bit counters, which meant that a counter would roll over, sort of like an odometer. That always happens. That happens on a regular basis, but not very frequently with SNMP v1. But with high-speed links, gigabit links, counters could roll over as quickly as every couple of minutes. And so on very high-speed links, InterMappers and all the measurements of data rates would be wrong a lot of the time. So they invented 64-bit counters in SNMP version 2. There were a couple of other things that were added in. So SNMP version 1 and 2 are similar, except that you can get 64-bit counters in version 2. SNMP version 3 is a very different beast. One of the problems with both versions 1 and 2 is the community string, which, remember, is like a password. That community string is sent in the clear. So if you break out Wireshark and you look at the packets flying by, you can see all the community strings. This is an interesting security problem. And so SNMP version 3 was designed to encrypt all the data in the packets. And rather than having just a single community string, there are actually a bunch of settings that you can that you need to perform. You need to select an encryption algorithm. You do need to select the what amounts to the password. And when you set up a device using SNMP v3, I don't have any handy for a demo, but when you set, I can show you the set probe window. There. So if we set info set probe, and if we do choose SNMP v3, you get just the port is there. You need to choose the authentication method and the authentication parameter, the username, and then all these parameters. So you need to set up these for the particular device. So that's how you do SNMP v3. Right.
Great. Thank you, sir. We have had a few questions come in, but you know what? We're right at the top of the hour, so I will make sure that we capture and save all of these questions, and we'll get answers posted to the forum at intermapper.com. If you could, okay. I'm going to take control because I'm kind
Go
of
ahead.
a
Yes.
freak.
All right.
I just want to thank everyone for joining us, and I will remind you again about the. Oh, I thought I had the probe contest information on my slides, but I don't.
Okay.
So we will be sending out an email with a link to the probe contest. Again, remember at intermapper.com, you can enter and upload your probes. We're really looking forward to some of the ones. We've already gotten quite a few, I think.
There are many juicy ones, yes.
Yeah, so it's been it's been a good thing. So thank you, Rich. Even I, when this is done, will be able to write a probe, I think. How about that?
Okay, that'll be great, Pat. Thank you, everybody. I've enjoyed doing this.
All right, thanks, everyone. Have a great day. Those of you that are suffering with bad weather, hang in there. We'll see you next time.
All righty.